Okay, everyone. Hi. So this is a continuation from what we left off in class. So over here we have this word problem about Nick, Joe, and Kevin, who are brothers. The sum of their ages is 83. Nick is 5 years younger than Kevin, and Kevin is 2 years older than Joe. How old is each brother? So we started a bit on this problem. We started annotating it. So you have your numbers circled, your question underlined, and your math key terms boxed. Okay? So from the question, we know that we have to find the ages of each of the brother. And here in our variables, we named each variable N is Nick's age, J is Joe's age, K is Kevin's age. So we're not just talking about the numbers of brothers or who the brothers are, but we're talking about their age. Next, we want to go ahead and start writing our systems of equations. So in this problem, we were just taking them sentence by sentence. So in the second sentence over here, the sum of their ages is 83. Sum is plus, right? It goes with addition. And 83 is that number. So that means if we add up their ages, now we don't know the ages, but we have the variables that stand for their ages, N plus J plus K, that should equal 83. So that's what we're writing. N plus J plus K is equal to 83. Now in the second part, Nick is 5 years younger than Kevin. So Nick is 5 years younger than Kevin. 5 is circle, younger than is boxed, right? So if we wanted to write this as an equation, Nick is, N is equal to, because we're talking about his age, and how do we find his age? 5 years younger than Kevin. You want to take Kevin's age, who's the oldest, and you want to take away 5 from that. So N minus 5. Sorry, K minus 5. Now we're up to this one. Kevin is 2 years older than Joe. So Kevin is, K is equal to Joe's age, 2 years older. So we, instead of taking away years, we're going to add on years. K is equal to J plus 2. So that's going to be our third equation, right? So let's go ahead and put this equation next to our system. So there you have it. We have all three of the equations taken from this problem. Now, we have to take this whole system, and we either need to use substitution or elimination to solve it. Now, there's a lot of us who are wondering, I don't know when to use which method. Well, the thing is, if you look at this problem, right, notice how we have N and K isolated. We have them isolated right over here, right? So because we have N and K isolated, that's a good signal for us that we need to use substitution, right? We need to substitute everything. Now, it's kind of tricky because you're not sure which one to start with, right? Should I substitute the N first or the K first, right? Whatever you do, you want to make sure that everything is in one, everything is in one type of variable so that we can solve for what that variable is. Like for example, in the first equation, if everything was in terms of k, right? If k was by itself, then it would be easier for us to find out what k is, right? The same thing if j was by itself or n is by itself. We won't be able to do it here because we have both n and k, k and j. We have two variables here, so it's hard for us to find it. So we want to get everything to just be one variable throughout. All right, so let's say we started with n, and we just decide to substitute n in the first equation. So I'm going to rewrite that equation. N plus j plus k is equal to 83. Now, according to this code, wherever I see an n, I need to write down k minus 5. So let's write that. K minus 5. And then we have plus j plus k is equal to 83. At this point, you can go ahead and combine like terms. So we see 2k's, so 1k plus 1k, that's 2k. We'll just bring down that negative 5 and that j. And then at this point right over here, you want to move away this 5, right? That's a constant. It doesn't belong with the variables. So let's bring it with its other constant, the 83. So we have 2k plus j is equal to 88. Now this doesn't tell me anything because we have a k and a j in there. So we need to like exchange one of the variables for something. So lucky for us, we already know what k is. We had a special code in the very beginning. So k over here, you can replace it with that k. So instead of writing 2k plus j, right? So let me just rewrite over here. You can write j is equal to 83. You can write 2 times j plus 2 plus j is equal to 83. Now what's great about this is that everything is in terms of j. Notice how j is the only variable here. So first you want to go ahead and distribute because there's a 2 in front of the parentheses. So 2 times j, that's 2j. 2 times 2, that's 4. Plus j is equal to 83. At this point, you want to find the like terms. So 2j and j, they both have the same variable. They're like terms. So that's 3j. And then we have plus 4 is equal to 83. So you want to subtract 4 on both sides. Oh, no, it's not equal to 83. It's equal to 88. Yeah, I was wondering what was going on. 88, 88, 88. So we subtract both sides by 4, and you're going to end up with 3j is equal to 84. And when you go ahead and divide both sides by 3, you're going to get, so if we did 84 divided by 3, that's a 28. So we just found this one. Joe's age is 28.